let's talk about two characteristics of the parabola, the focus and the directrix. Now, when you define a parabola, the definition of a parabola is a set of all points in a plane that are the same distance from a fixed line and a fixed point not on the line. The fixed line is the directrix and the fixed point is the focus. If I have a vertical parabola, then the focus lies on the axis of symmetry and the directrix is either above or, in this case, beneath the vertex of the parabola. The focus is the same distance from the vertex as the directrix is. If I have a horizontal parabola, then the focus again lies on the axis of symmetry, and the distance from the focus to the vertex is the same as the distance from the vertex to the directrix. The directrix will be a vertical line for a horizontal parabola. Now, let's have a little bit of fun. Suppose I have a vertical parabola here, and my focus is located at 0C. I know that the focus is the same distance from the vertex as the directrix is. Now, in this case, my vertex is 0, 0. We're going to use this because it's going to make the derivation fairly easy. So if the focus is located at 0C and the directrix is a line y equals minus c, let's see if we can find what these distances are. The distance from 0C to a random point on the parabola, xy, is, well, let's go back and use the distance formula. The distance formula is a change in x squared plus a change in y squared. So what is, let me call this d1. So what is d1? All right, it's going to be the square root of, well, the change in x is going to be what? X minus 0 squared plus the change in y, which is y minus c squared. Let's look at what the second distance is. This distance right here, I'll call it d2. All right, d2 is the square root of the change in x. Well, this we're going from xy to x minus c. So the change in x is actually 0, but I'm going to write it this way anyway, plus y minus a negative c. All right. Now, in order for the point xy to lie on the parabola, these two distances need to be the same. So let me set them equal. So d1 has to equal d2. Now, do you mind if I go on and square those before I write all that out? Because if d1 is equal to d2, d1 squared is equal to d2 squared. So d1 squared is, this is just x squared, plus y minus c quantity squared. And this has to equal, let's see, that's 0. So 0 plus y plus c squared. Oh, what a mess. Let me multiply this out. X squared plus y squared minus 2yc plus c squared has to equal y squared plus 2yc plus c squared. All I did was FOIL those two terms right there out. Let's see if anything simplifies. I have a y squared on both sides. I have a c squared on both sides. All right. So I'm going to continue this up top here. What am I left with? On this side, I'm left with x squared minus 2yc and 2yc. Okay, so x squared minus 2yc is equal to 2yc. All right, so let me add 2yc to both sides. So x squared is 4yc. So solving this for y is equal to x squared divided by 4c. Now, isn't that interesting? The standard form of a parabola located at the vertex is this standard constant 1 over 4c times x squared, where the focus is at 0c and the directrix is at y equals minus c. So if you have the parabola in standard form, you can do some manipulation to the coefficient of the x squared to determine the focus and the directrix. Here's a summary chart. When you have a vertical parabola and it is located at the origin, then y is 1 over 4c x squared. The focus is at 0c and the directrix is at y equals negative c. What happens when we shift it, when we move the vertex? The same thing when we did all the transformations before. If the vertex is at hk, then we're going to have a 1 over 4c times x minus h squared plus k. The focus will be at h, k plus c, and the directrix will be at y is equal to k minus c. We are going to do horizontal parabolas. For a horizontal parabola with vertex 0, 0, you have the same standard form. The focus is at C0, those two are switched. And the directrix is going to be a vertical line, x equals minus c. If we have the vertex at hk, then the equation for the parabola, it's going to mock the one for vertical. X is 1 over 4c, y minus k squared. Now, what it's got to be the k, so this goes with the y value, plus h, so you should see some symmetry here. And the focus is at h plus c, k, because what we're changing here with a horizontal parabola, the focus will shift in the x direction. And then the directrix will be a vertical line, x is h minus c. So yes, my students need to memorize or be able to derive. I like making you derive them.